Alright, welcome to an introduction to vectors. This is sort of our first day on it, and we'll just start out today with some definitions and looking at some real basic parts. In this first part of the video, I decided to break today's video into two different parts, so this one will be an introduction, and the next one we'll work in a little more in depth with them and apply it a little bit more. And looking here today, so vectors. What is a vector? We started to discuss this a little bit yesterday in class, but a vector is almost like the cartoon that says a vector has both magnitude and direction. And the magnitude is really just our size. So if you can remember the magnitude and direction, just like he says on the Pixar film, that's all a vector is. A quantity that has no direction, so if we're thinking of a value with no direction, that's called a scalar. And an example of a scalar is speed. So if I say I'm going 60 miles per hour, that indicates no direction. I just know how fast I'm going. It's just got a value with it, but it doesn't have the direction. When I add a directional component to that, I'm going 60 mile an hour northbound, then we have a vector. We have the direction and the speed, or the magnitude, or the size of it. Alright, we're going to use directed line segments to represent vector quantities. And so, seeing that as a picture, it looks just like a ray used to in geometry. And so it indicates which direction it starts at. The starting point is going to be called the tail. And then the end with the arrow on it, we're going to call that the head. And then the actual length of this is called the magnitude. I did make a remark that this resembles the ray from geometry. The key thing is a vector is truly a line segment, so it doesn't go on forever. It stops, it has that distance. That distance is the magnitude. It's just got the arrow on one end to indicate which direction, to distinguish tail from head. Alright, vectors are equal if they have the same direction and magnitude. So it has to both be completely perfect to be an equal vector. Alright, let's move on to vector addition. Let's say we have vector A and vector B, and you can see vector A has its length and direction, vector B has its length and direction. When I add these together, I'm basically going to go copy what vector A looks like exactly, keeping the length and direction the same. And then on the head of A, I'm going to put the tail of B. So I'm going to connect it perfectly. And then going from the start to the final ending point, that is what A plus B is going to be. So when we do vector addition, we just put the two vectors and add them end to end basically, and wherever they end up, that would be the result. Subtraction for vectors will work this pretty similar, given A and B. The only thing with subtraction is it's going to be vector A plus a negative vector B. So we're just going to change the magnitude on vector B. So there's my vector A. That would be adding vector B, and then the red line I'm going back would be the negative B. And so my green resultant there would be A minus vector B. So that's how vector subtraction looks in picture form. Next video we'll deal a lot more with using some numbers with this. And then sort of the last topic for this video is going to be scalar multiplication. And like I said, scalar is just basically a number out front with no direction. It's just the magnitude. So if we have vector A and I want us to find 3A, all we're going to do is take vector A and increase it 3 times, and that would be vector 3A. So scalar multiplication is just like multiplying by a constant. You can also remember some of this vector stuff back in matrices. You dealt with it just a little bit. Alright, that concludes this first video, just where I wanted you to see sort of the graphical pictures of what vector addition looked like, vector subtraction, vector multiplication, and getting some of your basic terminology for what a vector is and what a scalar is and sort of how the picture looks like. We'll continue in the next video with actually working with some numbers and dealing with more of the problem.